Hello, a Rosie math teacher coming at you from my 4th period accelerated 7th grade math class. And today we are in a new volume 2 textbook starting on page 5 for lesson 7-1, relations and functions. However, as usual, Miss Rosie has decided there's a simpler, easier, slightly more fun way to learn today's lesson. Now look at the two key words, relations and functions. I like to think of numbers as if they're little humans going around on planet Earth, right? I also want to change these two words just a little bit. I think, of course, middle schoolers are too young to be in a serious relationship. So let's just think about Mrs. Rose and Mr. Rose. We are in a relationship that I would say is functional. What makes it functional? Because we put into our relationship good things. And so good things come out, right? Okay, so when you are in a relationship, think about the things that make that relationship functional. Now, I know by middle school kids think, oh, of course we have boyfriends, girlfriends, all that kind of stuff. I felt that way in 2nd grade. I'll tell you a true story. I was in a relationship with a boy named Steven until one day when Steven cheated on me. Do you know how Steven cheated on me in the 2nd grade? He bought a piece of bubble gum for a girl named Ginger. And he did not buy anything for me. And so I was like, bye-bye, Steven. Yeah, you cheat on me with someone else? We're done. And that's what we're doing with today's, listen up, that's what we're doing with today's numbers. I really feel like this scenario, some people, not many, but some people can relate to, and that will help them to remember forever and ever how to tell if their relationship is truly functioning well for them. Let's continue. Now, for a moment, just bear with me. You're going to be like, what the heck does today's math lesson have to do with what you're talking about? Trust me, it'll make sense soon. First, let's read the long and boring explanation in the math book. A mathematical relation exists when two mathematical values are related in some way. A relation is any set of ordered pairs. So, my dear sweet students, do you see a set of ordered pairs inside my red box? Yes, you do. Please draw an arrow from the word relation to a box around those ordered pairs. Why is it called a relation? Because it is showing a specific set of ordered pairs. Once you have marked that, let us continue on. The input or domain of the relation is the set of x coordinates. Class, circle those two synonyms, input, domain, and draw an arrow from those words to your x column in the table. From the word input, from the word domain. I don't care what direction your arrows go. I'm trying not to write on top of other things. Do you agree? You understand that in this lesson, anything in the X column is a part of the, what's the first word? Input. Or we might say it's a part of the domain. Here's where I connect it with humans. Input in the domain makes me think of the first person to pursue the relationship. They put in the work. They did the input. And guys, if it ends like me and Mr. Rose, you end up moving into your own domain together. It's called a house. Now, where do you typically live when you're in your domain? In the house or outside the house? In the house. Can these correlations help you remember that input means in the domain or in the house? Will that help you put those two words together?
Yes, ma'am.
Okay. Now, I'll relate it again in a moment. Okay, so the input or the domain of the relation is the set of what coordinates? x coordinate. So let's say, for example, in the x column, the first item I see is -2. So -2 is the one. We'll let -2 be Mr. Rose. It was one Sunday after church, and he was like, oh, I haven't met that new girl yet. I heard her name's Angie. I'm going to go over there and introduce myself. So we're going to pretend Mr. Rose's name is -2. And then he came up to me. My name is what? 3. And he said, hello, my name is -2. What is yours? Something like that. He didn't actually say my name is -2, but you already realized that. Okay, so at that moment, who was putting the effort into beginning that relationship? -2. Forevermore, the only one that we are really the most concerned with is the input person, the one who started the relationship in the first place. That's the only one we care about, making sure they stick with that one person they chose. They better not cheat on them. They better not give a piece of bubblegum to someone else. Okay, so -2 is only going to give a piece of bubblegum to 3. And 0 is only going to share a piece of bubblegum with -1. And 1 is only going to share a piece of bubblegum with 2. And 3 is only going to give a piece of bubblegum to 1. Do you follow what I am saying? So clearly, -2 is only with 3. 0 is only with -1. 1 is only with 2. 3 is only with 1. Are we all good? They are all being good people. Yes. Okay. So we are saying that their relationship is what? Functional or not functional? Functional. So guys, write an F beside this table to show that every input is matched with only one output. Therefore, they have started and they have kept a functional relationship. Do you follow what I'm doing here? I'm simultaneously using real words from the real world with our math words from the math world. All right, let's continue. The output or range is the Y set of coordinates. So guys, circle the word output, circle the word range, draw an arrow from both of those to the column that is labeled with Y. Why? Because all of the Y values are known as the, give me the word that starts with O, output. So they are outside of the domain. They're out on the range. The range, do you think of a farm or a ranch? Out on the range. Or lovely. Yes, we have another type of range they're thinking of. Of course. Please don't yell it out. Where you practice your certain type of skills. And that's fine on that range. Just don't ever bring that equipment to a school. Thank you so much. So, out on the range. Now, I'm just going to tell you, in my made-up story, because I am making up some of this. Okay. In my made-up story, we only care about the input person, the person who started the relationship. But if the one who's out on the range is not always making the best choices, we don't care about them. We're just going to say if the person in the input is faithful to only one person, then it's a functional relationship. If the person in the input is buying bubble gum for somebody else, then we're going to say it's not functional. Let's do a practice right over here. In fact, I want you to go to the second page, go straight to the one on the right. This is called a mapping diagram. And y'all, look in the input column. Who do we see in the input column right away? 1. 1 is seeing 3. And then 1 bought a bubble gum for 5. Oh, no. This is not what? Not functional. Please write NF, not a function. Are you good with understanding this? Now, let me ask you this. On the output, remember that's also known as the range. And remember I said the people that are outside the house, we don't really care about what they're doing. We're not worried about them. They have nothing to do with the function or not a function. So would you ever say it's not a function because of 5? Since 5 is sharing bubblegum with 1 and with 2?
Yeah.
We would not say it's not functional because of that. No, because remember, if they're out on the range, we don't care about them. We're just worried about the choices of the input column. We're only worried about them. All right, so let's look at the first mapping diagram function. Is this a function, yes or no? Yes, because for every input, there is only one output. For every person in the domain, there is only one person in their range, the output. All right, let's look at another example down below. Input. 1 is seeing 1. 1 is seeing -1. Function or non-function? Non-function. Put NF beside that. Let's go to the next one. 2 is seeing -1. 4 is seeing -5. 4 is seeing -7. Oh, no. Class, what is this? Non-functional. We thought he had mended his ways. Oh my. All right. Let's try another one. All right, guys. This time, I want you to look at them when they're just written as numbers, ordered pairs. Remember, these ordered pairs show a relation. Yes? What is the first value of every ordered pair? X. So the 4 is an input number, isn't it? The 6 is an input, a part of the domain. Are you following? Everyone, underline all your input numbers, all of the members of your domain. First we have 4, then 6, then 2, then 10. Now let's see who each of them maps to. 4 is seeing 7. Is 4 seeing anybody else in the other ordered pairs? No, so we're good. 6 is seeing 8. Is 6 seeing anybody else in the other ordered pairs? No, so we're still good. 2 is seeing 0. Is 2 seeing anybody else in the other ordered pairs? No, so we're good. 10 is seeing 12. Is 10 seeing anybody else in the other ordered pairs? No, so we're good. So is it a function or not a function? Clearly you see it's already labeled. But do you understand why?
Yes.
All right, let's look at the second set of numbers. Ordered pairs, relation. This time, underline every X value. I would like everyone to underline every X value, please, and thank you. Underline the first value in every ordered pair. Is there any other 54 seeing somebody? No. Is there any other 56 seeing someone else?
Yes.
Shame. So this is what? Not a function. All right, we're moving on. Guys, let's look at our set of data down below. I want you to use the ones in bold print first. Underline all the input, all the domain. Go. Do yours match mine? Okay. Can you tell at a glance, function or not a function? Function. There's only one value of X, and then each has only one value of Y. Each input has only one output. Class, underline all of your X values in this set of data. Underline all of your X values now. Oh, I hear some people making a discovery. Who has been very, very bad and they're sharing bubble gum with too many people? So this is what? Not a function. They're catching on fast, y'all. I told you this would help. All right, now we are learning another way to tell. Another way. If your information is graphed, guys, this one's even easier. If your information is on a graph and you need to tell if the graph is showing a function or a not function, here's the test. Grab your pencil right now. Begin to the left of your line, and I'm going to use, actually, my stick here. Okay, as I start at the left, at this moment, how many pieces of the line are behind my pencil? Only one. Only one piece of the line. 1 point on the line is behind my pencil. Starting here, there's 1 point of the line, it's behind my pencil. 1 point of the line, it's behind my pencil. Point. Does it stay with only 1 point of the line behind my pencil?
Yes.
Okay, What this means is that for every input, we have only one output. So we would say it is what? A function. If it passes the vertical line test, are you sticking with just me, the pencil? Oh, line underneath. Now, go to your next page, please, class. Again, use your pencil from left to right. Only one part of the line under my pencil, but now there are what? Two parts. That means some of my input numbers have more than one output number. So we say it is what? Non-functional. Now, here's what's important though. Keep your pencil vertical. Vertical, like this. So go down to the next chart. It looks very similar, but wait. Is there more than one point under my pencil at any time? No. So if there's only one point under my pencil at every time, there is only one output for every input, which means this shows what kind of relationship? Functional. You guys are doing amazing. Now we have another page where instead of the curved or straight lines, they have given us some plotted points. Please again do the vertical line test. Draw your pencil across. Stop over the first dot. How many dots are behind my pencil? Only one?
Yes.
Yes. Second dot. How many dots are behind my pencil? Only one? Yes. Stop on the third dot. How many dots are behind my pencil? Only one? Ooh. That means there's more than one output for a single input, and therefore we say what? Cheater. NF. Not functioning. Not a function. They're catching on. Can you tell? All right, here we go. Determine whether this relation shown in the graph is a function. Let's begin at the left. Stop over the first dot. Is it above only one dot? Yes. Only one dot?
Yes.
Only one dot?
Yes.
Only one dot?
Yes.
Only one dot?
Yes.
What is it?
Functional.
All right. I think you guys know this lesson very well.